Hey geometry students, welcome back. In this video, we are going to be working with the midsegments of triangles. And working with the midsegments of triangles is fairly easy, as long as you're not doing a proof, which we're going to do in letter B. That's going to be a little bit complicated. But let's see how easy it is to work with midsegments in like regular geometry type problems where we're trying to find the lengths of things. So let's go to letter A. In letter A, it says that TU is the midsegment of QRS. Find the values of X and Y. Well, okay, so we know that the midsegment is half the length of the opposite segment that it's the segment that it's not touching, right? So 12 has to be half the length of x. X equals 24. All right, and then y. Well, let's think of the definition of midpoint. A midsegment connects the midpoints of two adjacent sides of a triangle. So that means that if this is the midpoint of QR, y has to be the same as the other side of the midpoint. So y equals 8. Pretty easy, right? All right, now here's the things that are tough. We got to do a proof. We need to prove theorem 55.2, given that DE is parallel to BC and D is the midpoint of AB. I need to prove that E is also the midpoint of AC. I'm going to do this as a paragraph proof. So we're just going to write out statements, and I'm going to justify each statement in a sentence, okay? And let's see. This paragraph proof is going to be based on, I'm guessing, and what I'm going to try to do this is based on triangle similarity. If I can prove that the big triangle ABC is similar to the little triangle ADE, then I know that whatever the ratio is between AD and AB has to be the ratio between AE and AC. I'm going to start off with this statement. If D is the midpoint of AB, which we know that it is, it's given that D is the midpoint of AB, then AD is congruent to DB, right? That's the definition by the definition of a midpoint. Then, so I know that AD is congruent to DB because D is the midpoint. Now, what I can say is AD plus DB equals AB by the segment addition postulate, right? This small segment plus this small segment equals this long segment. And AD, because AD and AB are congruent to each other, okay? AD and DB are congruent. I could just say AD plus AD equals AB by substitution, property of equality. I'm just going to call it substitution. So 2AD equals AB. Okay, so one AB is 2 times the length of AD. So I know that that's true because it is given that D is the midpoint of AB. So 2 of these ADs equal AB. Does that all make sense? I very methodically showed that. All right, now let's go to the next part of this. I can prove, so now I got a similarity ratio between AD, small triangle AD, and big triangle AB, if I can prove that these triangles are similar. Let's try that. So I know that angle A is congruent to angle A by the reflexive property of congruence. This top angle is congruent to itself. That's a good sign for these triangles being congruent. But now I have to prove that angle ADE and ABC are congruent. But wait a second, AB is a transversal. AB is a transversal across parallel lines, DE and BC. And that's given at the beginning, basically. I know that these two lines are parallel at least, and then I just, by the definition of a transversal, technically I'm applying the definition of a transversal here to state that. If AD is a transversal across parallel lines, or AB is a transversal, same line, then what I can say, so angle ADE, I should say angles ADE and AB, and let's see, where'd my ABC down there, are corresponding angles. ADE and ABC are congruent by the corresponding angles theorem. Okay, ADE and ABC are congruent. And now this means that triangle ABC is congruent to triangle ADE by angle similarity. Oh, congruent. Blah, wrong. Similar to triangle by angle similarity. They have two of their angles the same, A and ADE ABC. All I need is to prove that two angles are the same. And now that I have similar triangles, I know that by the converse of the side similarity theorem, the ratio of similar sides, I should say the ratio of similar sides of the triangles is always the same. And then let's just note that I already said that 2AD, so 2 times AD equals AB. So by that side theorem, I'm going to say that 2AE equals AC. Okay, 2 times AE equals AC. But wait a second. If 2 times AE is going to be equal to AC, that means that AE, so one, I'm just rearrange this. This is the division property of equality. So AE equals 1/2 AC. Oops, I forgot an equal sign. AE equals 1/2 of AC. And if I have a segment that's 1/2 of the other segment, so if AE equals 1/2 of EC, that means that, or AE equals 1/2 of AC, EC must be the other half. EC must be the other half of AC by the segment addition postulate. And if both of them are half, and that means that if they're each half of the same segment, that means that they have to be congruent to each other. AE and AC are congruent. Therefore, we would say, I keep mixing this up. AE and EC are congruent. Therefore, E is the midpoint of AC by the definition of a midpoint. Okay, so let me just have 2AE equals the long one, AC. AE equals half of AC by the division property. I should really put that in there, by the division property of equality. EC must be the other half of AC by the segment addition postulate. So AE and EC are congruent, therefore E is the midpoint of AC. Basically what I did at the end here is I just worked this part backwards to prove that E is the midpoint of segment AC. All right, and we did it. So that's how I would do that in a paragraph proof. This isn't really an elegant paragraph proof, but it's a paragraph proof that does prove that if this is half of this segment, then it has to be the midpoint, and we can prove that these triangles are similar, so this has to be half of AC. All right, let's continue onward to letter C. I'm going to shrink this down. We're going to just shrink our font size here so that we have some room for our other problems. All right. let's move on to letter C. Letter C, triangle FGH has vertices at F, negative 2, 4, G, 6, 2, and H, 2, 1. DE is a midsegment of FGH. Find the coordinates of D and E. Well, that's easy because I'm just going to use the midpoint theorem, or the midpoint formula. So if this is 6, 2, I'm going to do, let's see, for my X midpoint, it's going to be X1 plus X2 over 2. Okay, let's just fill that in. X1 is negative 2 plus X2 is 6. Negative 2 plus 6 is 4 over 2. So my first coordinate, 4 over 2, is 2. And then it's going to be y2 plus, y1 plus y2 over 2. Let's see, y1 is 4. So it's going to be 4 plus y2 is 2. 4 plus 2 is 6 over 2 is 3. So 2, 3 is the midpoint of the first one. Now I need to find the midpoint of this segment. Negative 2 plus 2, well, the x-coordinate is 0. And then this one is 4 plus negative 1 is negative 3, 1.5. And I can just look at where these points are situated, verify. This is 2, 3. This is 0, 1.5. So find the coordinates of D and E. Well, that was actually really easy. I probably could have done that by inspection of the graph. Letter D, find the perimeter of mid-segment triangle. Now for this one, we have to just pull out all the stops and use all of our tricks that we know. For example, I know that if this is a mid-segment, it has to be half the length of the opposite side. So for this one of my mid-segments, we're going to say the mid-segment on XY is going to be half of 14. So it's going to be 7 plus. This mid-segment over here is going to be half of whatever this is. This whole side over here is 10, so half of 10 is 5. 7 plus 5. But now we have to figure out the bottom length. But hey, if this is a midpoint, I know that this equals this. 2x plus 4 actually equals 3x plus 2. I'm going to subtract 2x from both sides, okay? And I'm going to get 1x on this side, because 3x minus 2x is 1x. So x plus 2 equals 4. Subtract 2 from both sides, I get x equals 2. If x equals 2, 2 times 2 is 4, plus 4 is 8. That means that one of these is 8. 2 of these is 16, so the whole length here is 16. That means that this midsegment is 8. 7 plus 5 plus 8. 5 plus 8 is 13, plus 7 is 20. And then lastly, in the diagram, 4th Street. Okay, this one you just basically have to keep track of what we're talking about. 4th Street is a mid-segment of the triangle formed by Baker, Lowry, and 5th Streets. Jeremiah leaves his house at the corner of 5th and Baker, so he's leaving here. He walks down 5th Street, turns left, and walks up Lowry Street until he reaches the corner of Lowry and 4th Street. How far has Jeremiah walked? Well, okay, so this is 11 meters. If this is a mid-segment, that means the bottom one is double. So he walked 22 meters, and then to the midpoint of 10, 22 plus 5 is 27 meters. And that is how you use the mid-segment theorem. All right, I know this was paragraph proofs always come out to be a little bit more train of thought. So maybe that was a little bit rockier, but we were able to use we were able to solve the problems. For next time, you will be solving the problems associated with this lesson.